welcome to this quick session about the VibLyze software from VMI. My name is Salah Attia. I'm a condition monitoring specialist and I'm working in this field for about 18 years now. I'm certified level 4 in vibration analysis and I'm the technical director for MCS, Machinery Consultation and Services, based in Australia. MCS is a distributor for VMI products in Australia and New Zealand. We're selling their products and also we give training on how to use them. Today in this quick session, we're going to talk about the VibLyze software and we will talk about the creating the database. The VibLyze software is one of the easiest software to deal with. We have many complex softwares in the market at the moment, but this one was one of the easiest. Pretty easy to use and yeah, straightforward. Let's have a look now how we can create the database. After you open the software, as you can see here, you need a dongle to open the software with license. And the software is pretty easy. You can download the software from the VMI website, but you need to have the dongle. The dongle has been sent as part of the buying the product. So if you purchase the product, you will get the dongle with it. And the training session, it can be found on the YouTube now. And if you would like to know any information about the software, please feel free to give me a call at any time or contact me by email. So let's go here. You can click on the database, manage database, and then you want to create a new one. So you can go here, create new database. You can use the software with Viber X5, X4, and X2+. We'll use the data with the Viber X5, so you can call it demo bump and then create. So this is our database. Once you create the database, you can click here, set active, and then close. As you can see here, now we have demo bump. This is our database name. So we can add an area or department, and once you have the new department, you can rename it. So for example, if we are talking about the factory or power station or whatever, let's say we have the area 1 dash bumps. So this is the area 1 which have all the bumps. And then you click save changes. Now you have the area 1 which have the bumps. Then when you make right click, you will start to add machines to this area. Add machine. So the new machine, you can give it a name. So this new machine, we will call it bump 1. You can put a description. Let's say hot water pump. You can add a detailed description for this pump. Like, is it belt-driven pump? If it is direct, you have a gearbox. You can add the image of this pump as well. If you have the running speed, you can add the running speed here. The secondary reference speed, if it's belt-driven, so you have 2 different speeds, so you can add them here. And then you can go for electric motor defects, motor running speed, primary speed, 50 Hertz, the line frequency, like you have 50 Hertz your line frequency. If you have the ball burst frequency, let's say you have 2 balls motor, the number of rotor bars like 56 for example. So you can add all the information you need. If it's belt-driven, you can add the primary speed, this is our ball speed, belt frequency, and you can add the belt length, you can add the pulley pitch diameter if you like, multiples if you have a gearbox, so you can add different speed reference. So you can have all this information and then save it changes. And now you have the bump 1. Inside this bump, you have motor non-drive end, motor drive end, bump drive end, and the bump non-drive end. So you will start to add the vibration point. So the first point we have, you can name it here. Like this is the vibration point. You can add the point name motor non-drive end. The shaft speed, defined speed 50 Hertz. You can have shaft speed configuration, if you have gear, if you have a coefficient, and then you can have the bearing number, so you can add the bearing. If you click here, you can have the bearing library, so you can have, for example, SKF bearings, for example. You can have them here, or you can search from here, SKF bearing, so you can have all the bearing number, and then you can search by the bearing number, and then once, for example, you click here, then you will get the selected bearing information. You can see the outer race, inner race, gauge, and rolling element changes. So you can have the bearing number you want, and then add the bearing. So you can have all the bearing information, outer race, inner race, gauge, and rolling element with the bearing frequencies already calculated because you have the running speed. You can remove the bearing, replace the bearing, or add the bearing. Then save changes. So this is the motor non-drive end. Now you want to add the direction. You would like to measure at 3 directions: horizontal, vertical, axial. So you can name this one H, or horizontal. Save it change. So you have horizontal direction. Add another direction. Here, this one. Vertical. Save. Add another one. Axial. Save. So you have the 3 measurement directions for the motor non-drive end. When you go, for example, for the horizontal direction, it's pretty easy to adjust your spectrum, how it looks like. You can have the frequency range. You can choose 400, 1600, 3200, and so on. You can choose the frequency range you want. And you can choose the number of spectrum lines for line of resolution. And you can choose the window type: Hamming, rectangular, the number of averages, the average type, linear, exponential, or peak hold, high pass filter, 5 Hz. You can also collect envelope acceleration data for early detection of bearing failures. You can have the alarm limits. You can adjust the units of the alarm in millimeters or microns or Gs. The detection type in RMS or peak to peak. What's the warning level in millimeter per second? What's the danger? So you can adjust your alarm. Bearing condition alarm. You can also adjust the warning, danger, and envelope alarm levels as well. So all those alarms, you can choose them and you can define them. Once it's all done, save it change. You can create more frequency range. You can create different frequency ranges. It's depend on how you'd like to see the data. Once this is done, it's pretty easy. Right click. When you click here, you add direction and add tri-axis direction if you have a tri-axis accelerometer, or you can delete the point. Now we have the motor non-drive end. As you can see here, you can make right click, or here right click, add direction. Then you will make add measurement point, a new one, and you can name this one motor drive end and save it change. And then you will start to add directions in this one as well. Horizontal, add direction, vertical, right click, add direction, and axial. Save it changes. So you can have motor non-drive end, motor drive end. Again, you can create, for example, the pump drive end. You can create the pump non-drive end, save, and you can add direction here, you can add direction here. And once you have all created, and as you can see, it is here still white, the circle near to the pump drive end, or no direction, because we didn't make the changes or save the changes inside it. Once you finish this, for example, you have the whole pump, you don't need to create a whole new machine. You can make copy, right click, and paste new machine. And then the new machine, you can name it, for example, pump 2. So you don't need to keep creating new machines. So this is one of the very good things, how to create the database. As you can see, it's pretty quick. And when you click here, direction, you will start to see the envelope, the vibration, and you can see the waterfall as well. I'm gonna see this in a different video, and you can see the vibration spectrum. You can reset the zoom, and we're gonna talk about the other parameters on the next video. Thank you so much for watching, and yeah, please feel free to call if you have any questions. Thanks.